Inverted page table structure. Before entering into this concept, first of all, we should know about simple page table and hierarchical page table disadvantages. When we use simple page table, if there are a huge number of page table entries, then it takes a lot of time to search a particular page table entry. So we have moved on to the hierarchical page table, where searching is easier, but in both the cases the page table must also be stored in the main memory, so that for a huge process it takes more main memory to store the page table. So to avoid this problem, a new method called as inverted page table structure was introduced. The main characteristics of this approach is there was only one page table maintained in inverted page table structure, and the page table size is fixed, which is equal to the number of locations in main memory. So as the name indicates, inverted page table structure. In normal page table structure, from the virtual address we get the page table entry. From there we access the frame number, and then we form the physical address to access a particular location. But here in inverted page table structure, the index of the page table is not the page number but the frame number. So the frame numbers are used as the index for this inverted page table structure instead of frame numbers. This is done using a function called as a hash function. Let us see this concept with this diagram. First, let me explain with an example, then we'll enter into the exact process. Let us consider n number of bits are used for indicating the page number. A hash function is used to convert this n bits of page number into m bits. As you can see here, the inverted page table is a fixed entry of size equal to the number of locations in the number of frames in the main memory. So if there are 2 power m number of locations or frames in the main memory, then 0 to 2 power m minus 1 entries are there in the inverted page table. So as we see in this diagram, the inverted page table is of fixed size, which is equal to the number of frames in the main memory. If the number of frames in the main memory is 2 power m, then the inverted page table size is equal to 2 power m, where the index for the inverted page table is from 0 to 2 power m minus 1. Let me explain this diagram with an example. Let us consider the page number indicated here is 5. So the value 5 is taken, which is represented by n bits. Let the output of the hash function is 3. So the page number 5 is mapped onto the hash number 3, which is nothing but frame number 3. So the page number 5 is represented in the table, inverted page table, as 5. The corresponding process ID is also entered, and the frame number for page number 5 is 3. If the entry in the inverted page table 3 is empty, then these details are filled in the page table. But if the entry is already filled for some other page number, then a new location or a new frame number has to be provided for the same hash value. For example, for the page number 5, it is mapped to frame number 3. If the entry in the inverted page table of index 3 is free, it is filled for the first time. If any other page number, for example page number 9, also leads to hash number 3, then the index of that particular entry is already filled, so a new location is allocated for that. So in order to maintain the new location where the chain of all the page numbers leads to a hash value of 3, to retrieve that information, a pointer called as chain is used. So when we follow the chain pointer, it shows the locations where further page numbers that leads to hash number 3 is filled up. Once when the frame number is known, the frame number is binded with the offset from the virtual address so that the real address or the physical address can be identified. These are the entries in the inverted page table. The page number, which has undergone for a hash value, and the process identifier, which is an integer value given by the operating system for every process to uniquely identify the process. Control bits, which includes some flags and protection and locking information, and the chain pointer, which point out the chain of index values leads to the same hash value.